Okay, so good news is today we are no longer creating the graphs. We've done a lot of creating. Today's focus is going to be just on reading and interpreting the graphs that we are given. All right, our first kind of graph we are given here is a pie chart. So the Illinois School Report Card provides a summary of schools in the state each year. The pie chart below represents the ethnic diversity of the 4,267 students enrolled at WTHS during the 2015-2016 school year. All right, so let's look at what we've got here. It says how many students at WTHS were white, Hispanic, African American, Asian, 2 or more races. So we've got, let's look at this. So first we are looking at white, and when we look at our pie chart, we're looking for how many. My answer is not going to be 46. I don't have 46 white students. It's representing 46%. So when the question says how many, I'm looking for a count, a number of how many based on that percent. Well, we are given 46%, and we have to, this is where it comes in to be really important about reading those directions. Up in the directions, I was told how many students were total enrolled. So what I want to do is I want to take 46% of the total enrollment, and we know that we changed the percent into a decimal. Problem is when we multiply those numbers out, it's not perfect. But we're not going to say 0.82 of a person, so we're going to go ahead and round that to 1,963 students. Hispanic. So according to our pie chart, we have 29%. So we take our total population, we multiply that by the 29%. Once again, we get a decimal, and we round that. We're going to go ahead and round this one down. The 0.4 tells me to go down, so 1,237. Why don't you go ahead and press pause and complete the 3 remaining categories. When you are finished, press play. All right, let's see how you did with your calculations here. So we multiplied by 11%. We rounded down because of the 0.3 for 469. The Asian population, we get 426.7. We round that up because of the 0.7. Now, sometimes we make a little mistake with this 4%. For some reason, we like to make 4% 40%, so that should be 0.04, not 0.4. 171. And then our last 2 categories that we have listed here, we have American Indians and we have Pacific Islanders. There is 0%. During this school year, 2015-2016, there was 0, so we don't have any there. If we go ahead and find the total, we add up 1,963, 1,237, 469, 427, 171, we end up with 4,267. Let's see what we should have done. All right, so this time it actually worked out nicely because we must have rounded up the same amount of times as we rounded down. That is not always going to add up because of rounding. When you are rounding data, there's always that chance for things to be off slightly. All right, next, what is the measure of the central angle that would represent the Asian students? So if we think back to geometry, long time ago, the central angle is the angle that is coming from the center of the circle. And the center of the circle, this angle, is going to be congruent to the arc measure. So we want to figure out how much of that piece of the pie are we looking at. And the Asian population is representing 10%. Well, how much is in our whole circle? 360 degrees. So I'm going to take 10% of my whole pie, 10% of that circle, which is going to give us 36 degrees. Just like we talked about before with the total number of people, the count, central angles don't always add to 360 because of rounding. All right, so that was a review of how to use our pie chart and answer questions. Next, the table to the right provides the salary information for several workers in a small business. What is the mean salary of the workers at this company? Now remember, you can do this by hand, or you can do it in your calculator. If you're going to do it by hand, you multiply across. So 50,000 times 2, this is representing 100,000. Multiply by 3, multiply by 4, multiply by 2, multiply by 1, and you get a total down here. You would want to review back to the day 3 notes. So let's see, day 3, right here. Actually, went right to it. On our day 3 notes, our last question was that frequency for the child price and how many tickets were sold at that price. We multiplied across. So if you forgot how to do that by hand, or you forgot how to do it in the calculator, you can go back here to remind you. That's not our focus. We have this in list 1 and this in list 2. This is when you change, when you go to calculate your one variable stats, you change the frequency list to list 2. But again, if you don't remember how to make those calculations, I want you to go back to your day 3 video and review those. We want to look at how to interpret this data. So we find that the average is going to be $79,083.33. What is the median salary? Again, you can do that by hand or in the calculator. We find that the middle is 75,000. This is where statistics can be skewed and somewhat abused by the people that are using them. Which number, the mean or the median, do you think the owner of the company would use to describe employee salaries if they were trying to attract new employees? So this is pretty obvious. Of course, we would be using the average. We would be using the mean. That's because it's higher than the median. If you're trying to attract new employees, you want to make them think they're going to make more and more money. People are going to take the job that's higher paying. So if I was the company trying to get employees, I would show them and I would advertise my average salary because it is higher than the median. So we think about, why is that? So it makes the company look better, look more desirable. Now, why is it higher? It's higher because it includes this boss's salary right here. So that boss's salary, which is significantly higher than the rest, is going to skew that data point higher. Remember, we talked about how the average can be affected and is more influenced by low and high scores. All right, part D, which number, the mean or the median, do you think someone searching for a job would prefer to look at? So this person would probably rather know what the median is, because the median is the middle. That's representing more of a typical salary versus one either that shows the really low or the really high. If they're going in, they want to know what the more typical salary is. So median it better represents what we say quote-unquote average or typical. We use average when we really shouldn't. Average in English terms is different than the average in math terms. So the typical employee is making. So it's not going to be influenced by that high-paying boss price instead. Backside. So now we've got this bar chart. The bar chart to the right illustrates the number of hours in a week that a gym offers yoga and running sessions each day. It's a comparative bar chart, so it's got those two right next to it, and we have the legend down here showing that solid is yoga, the dashed is running. Use the chart to answer the question. So again, using the graphs that were given to you, can you read and interpret them? What are the peak days for yoga? Don't be thrown off and just say, oh, the highest bar, oh, here's the highest bar right here. The winner is Wednesday. No, because we are looking specifically at yoga, and yoga is the solid bar. So we want to make sure that we don't get too eager. And we see that yoga is actually tied. The peak days are Thursday and Saturday. What are the peak days for running? All right, then now there's what we wanted to look at. Right there is running, and that is going to be Wednesday. What is the average number of hours each day that the gym offers yoga sessions? The average. So what we're going to do is we are going to look at our chart. On Monday, it offers 2. On Tuesdays, it offers 3, 3, 4, 2. And I'm just looking over here to the left to tell me how many is represented by each of those bars. 4 and 3. That is, so we add those up, 2 plus 3 plus 3 plus 4 plus 2 plus 4 plus 3. And the average, we take that and we divide it by how many days a week they run. 1, 2, 3, 4, 5, 6, 7. It's going for all 7 days of the week. When I divide, we get 21 over 7. So the average is 3 hours a day. So some days it only offered it 2 times and sometimes it offered it 4. But when you average it out, they on average offer it 3 hours a day. What about the number of days for running? So we've got 1, 2, Wednesday way up there at 5, 3, 3, 2, 0. So it's not running all 7 days of the week. It's only running 6 days of the week. 1 plus 2 plus 5 plus 3 plus 3 plus 2. You could add plus 0 and then divide by 7 if that makes you feel better. When we divide there, we get about 2.3 hours a day. Taking into account all hours that yoga and running sessions are offered in a week, what percent are for the yoga sessions? So we had 21 hours from yoga and 16 hours from running. So we have 37 total hours. What percent is for yoga? Well, 21 of the hours were for yoga out of the 37 total. When we divide that, we get about 56.76%. All right, our last graph here. The graphs below summarize the number of times a runner in training runs certain distances in order to prepare for a half marathon. What is the median number of miles covered for this runner in training? So if I'm looking at all this, yes, if I'm looking for the median, I'm looking for the middle number, and I could add up all these numbers in the histogram, but it's easier if I look at the box plot. We know that the box plot shows us the minimum, the Q1, and the median. So the median value is going to be 5 miles. We've got two different graphs here, so let's use the one that is better for those questions. Part B, 75% of all training sessions run were blank miles or less. So again, when I see this 75%, this is telling me I'm going to look at the box plot, because I know this is 25%, this is 25%, this is 25%, and this is 25%. So 75% of all training sessions were here or less. So I want 75% of my data to be below this amount, which means we're looking right here with 75% below, which is our Q3 value, which is 10 miles. This distribution is considered to be right skewed because there are just a few values that are to the right. So it tapers off, so it's going to be right skewed. And most of the data is to the left. What does this mean in context of the problem? Does that surprise you? So that means that there were just a few times that the runner runs long distances higher than 10 miles to prepare for the half marathon. To me, that surprises me because you think that they would run more to better prepare. And in case you didn't know, an important aspect to know here, if you're not a marathon runner, is that a half marathon is 13.1 miles. Again, I would think that they would run more to overcompensate. But for this one, again, there's just a few times that the runner runs long distances higher than those 10 miles. To prepare for the half marathon, they're normally running less. That's the answer to part C. Again, there's just a few times that the runner ran those long distances. Okay, and that is it for this one.